Okay, look at number 4. Number 4 says, if f, please don't talk right now, if f of x is x squared plus 1, okay, and g of x, oh, it's one of those kind. You got f of x, you got g of x. You can probably put the one on the other. And g of x is 7x minus 4. Then they ask you to evaluate this, f of g of 2. I know that I've emphasized this over and over again, but I hope you know. You start on the inside in hard math problems. Start on the inside, work your way out like the alien in the movie Alien. Yeah, if you take g of 2 then, I got to go figure out what g of 2 is. So I'm going to go up to the g function, which is this guy, and I'm going to stick 2 in. G of 2, see, is 7 times 2 minus 4. So that's 14 minus 4 is 10. Hey, I figured it out. Am I done? No. But I know that g of 2 is 10. So then it's f of 10. Then I got to put 10 in the f function. So then I just stick the 10 in here, and that'll be a piece of cake. 10 squared is 100, 100 plus 1, 101. You get how to do those? Okay. Next kind. You really didn't get that? Okay. I will show you another one that's like it. G of x equals x squared minus 3. F of x equals x minus 10. All right, if I put f of g of x, then I'm saying that which one is on the inside? The g. And I'd start with g and figure that out. But I need to figure out something like, what's g of, let's say, 4. So always start these on the inside. So g of 4 is that guy right there, except with a 4 in it. So that's 4 squared is 16. 16 minus 3 would be 13. Now the problem is f of 13. You get what I just did there? Okay. And now it's just a separate question. It's just ignore this. We've figured out a new problem. It's f of 13. So then I use the f function, which is this guy. Stick in 13. So it'd be 13 minus 10. It'd be 3. So you kind of do it in layers. You start on the inside, get that done. Then go to the outside function and get that done. All right. Moving on to another type of question that's kind of like that. Let's look at number 6. And it's asking you to figure out what the functions were so that when you put the one function in the other one, you got this answer. This one's called decomposition. 6a. So they're asking, here's a combined function that came out to this. Cubed minus 4. I'm going to pause for a second here. Okay, so this is the answer to a question where they put one function in the other function. F of g of x. Right now, what you should be doing is trying to answer problem 6a with me here. All right. So if this is f of g of x, that means that the g was on the inside, and you got to find part of this problem you're going to call g. There is more than one way to do it, but you pick part of the problem to say, let's say this was g of x. Let's say g of x was x plus 3. Something that's in a parenthesis or a bracket is a great thing to choose. Something that's in a square root, any little cluster of numbers, then those work well to be g. If that's going to be g, then I pull it out of this, and what do I put in place of it? X. And then my other function would have to be x cubed minus 4. This is called decomposition.
Where does the absolute value come from?
The absolute value would have to be in one of those functions. So I'll give you a final answer for this one. If g of x is going to be x plus 3, I'm going to pick out that part to be the g. That was the part that got put on the inside. See, g's on the inside. So there it is. It got put in right there. Then there must have been an x right there. And so then the whole rest of this function, absolute value of x cubed minus 4, absolute value, that is the other function. That's f of x. That way, if you check yourself, you can see I can put this g function into the f function right there, and I will get the original problem that I was given, which is this guy right here. This whole thing comes out when you put the G into the F. So you just take part of it out, call it G. When you're doing decomposition, just take part of it out, any part you want, but any little cluster is good. Grab that out and call it G of X. And then the whole rest of the function, that must be the F of X. All right, moving on to another kind. Inverse. Finding an inverse. There was a 3-step process for finding an inverse. Remember that? Judging by the fact you have 1, 2, 3, 4, 5, 6 questions on this, it's probably important. Okay, so I'd make sure you remember this process. I will write it down for A. Show you an example here. If f of x is square root of x minus 3, then to change that into its inverse, the first step was to change f of x into y. Do you remember that? Y equals square root of x minus 3. Now do you remember what was next? Switch them around. X equals square root of y minus 3. And why did we switch them around? Because now we're going to solve, and you always try to solve for y. All right, if we needed x alone, it would already have been alone right here. Okay, but we want x, or we want y to be alone with our new function. Okay, so how do I solve this thing for y? Square both sides. Square this, square that. When you're squaring both sides, does that introduce an absolute value? No. When you square root both sides, that would make an absolute value come in. But we're not doing that. We're squaring. So it's x squared equals, and when you square a square root, it just disappears. As simple as that. Y minus 3. And then I'm almost done. What do I do to get the y alone? Plus 3. Final answer is y equals x squared plus 3, or 3 plus x squared. Now, those are inverses. What does that mean? That means that their domain and range are exactly flipped. If any point on the original would have been like 5, 7, on the new one it would be like 7, 5. Everything's flip-flopped. I'll say that again. If the original function had 5, 7 on it, the new function would have what? 7, 5. It reverses x and y. Remember, we just reversed x and y. We took this guy and switched their places. So that's what happens on the graphs too. So if you have a graph of one function and it looks like this, for instance, and you want to know what its inverse would look like, you take any point along here, like that's the point 0, 1, and therefore what must be on the other graph? 1, 0. And the point, let's say here, negative 2, 1 means 1, negative 2. And if you completed it out, it would look something like that. And that is an inverse, and it's a reflection over this line. Do you remember that deal? It's a reflection across the line, y equals x. Inverses are a reflection across that line. So if this had been the point 8, 10 right there, then this would be the point, what? 10, 8. Wow. Okay, so inverses, a couple things to know. Their x's and y's are all switched, which also means the domains and ranges are exactly reversed. Inverses are a flip of each other across the line y equals x. And there's a 3-step process for creating an inverse. Change the f of x to a y, then flip x and y around, and then solve for y. Yes? Sure. All right, so on A, the one we were just doing there, this guy was A, this was the original. If I want to figure out the domain and range of the inverse, which is this guy, I do not just grab the inverse and find its domain and range. I go to the domain and range of the original and reverse them. So let's talk about the domain and range of the original one. The domain on this guy is what things work. So you should say to yourself, what are the things that don't work? And everything works except what? All right, so the domain on this, you want that part right there to stay positive, right? So therefore you want x minus 3 to be greater than or equal to 0. That's how you find a domain. Remember that part? So I'm going to say x is greater than or equal to 3. Would you agree if I put in a 3, I'm still okay? And if I put in things bigger than 3, I'll still be okay? Like 4 and 5 and 6? If I put in things smaller than that, though, if I put in like a 2, see how I get a negative under the root? All right. So my domain, you take what's underneath the root and set it greater than or equal to 0. I know it's a lot to process here, but I got to go fast to be able to have a chance to cover all this stuff. So, all right, so that's my domain. If that's my domain, x is greater than or equal to 3. What's the range? I would always make a picture to find your range. We are only going to give you ones, well, a picture is the easiest way, I'm going to say that, to find the range. So if I had a picture of this, I know square roots like that, like that, right? Except this square root's been moved where? What's that minus 3 do? Moves it right 3. So if I take this little graph right here and move it to the right 3, there's the original. Right 3 would mean like this. Now, what's its range? What's the lowest to what's the highest? 0 to infinity. So the range on this guy, 0 to infinity. Okay. Oh, wait, can it be 0? Yes, it can touch 0, so it should be a bracket right there. Now, I've got the domain and range of the original. Good part is, I can just flip-flop it to get the domain and range of this guy. This guy's the inverse, and so its domain and range are reversed. So the range becomes x is greater than or equal to 3, and the domain becomes 0 to infinity. Because again, our x's and y's are just flip-flopped. So our whatever was our y stuff, like the range, becomes our x stuff, the domain. Yes? There are all kinds of problems. I will help you with number D. All right, so I'm trying to teach you general principles here that you can apply to all of them. So your first step is to find the inverse, okay? And the original problem for D is 6 over x plus 4. And it's got an f of x right here, which I'm right away going to change to a y. That's the first step. And then you flip-flop the x and the y. X equals 6 over y plus 4. And then I solve for y. Anytime you have a fraction in your problem, you should try to get rid of it. So you multiply by the denominator, right? So I'm going to multiply by y plus 4. That'll make my life better because I won't have a fraction anymore. Then that cancels that, and I have, I'm going to say xy plus 4x equals 6. You got to remind yourself, which one am I solving for? Y, because I already had x equals right here, but I don't want that. I want y. So I'm getting y alone. I'm going to minus the 4x then. And I'll have xy equals 6 minus 4x, and then I'm getting close. Divide by x. No, wait. Divide by, what do I want alone? I want y alone, so I'm going to divide by x. Yep. Y is now alone. 6 minus 4x over x. There's your inverse. Okay, right here, you mean? The y plus 4 that canceled with the other y plus 4? That part would just be 6. All right, this part has to get multiplied out. All right, so I'm done with that one. I got my inverse. Now, to take that inverse and find its domain and range, don't look at this guy and say, oh, can't be 0 and that stuff. Don't do that. Go back to the original. You'll get it wrong if you try to do it off the inverse. The original is domain and range. Domain on that guy is what would work versus what would crash it. Looking at this, I'm not going to want to try to do the graph of it because I don't even know what the graph looks like. But I know the only one thing that would crash it would be -4. You get that? So I have to say x has to just, it can be anything, all reals, except x cannot be -4. You could have said -infinity to -4 and then -4 to infinity. It's a multiple, no, it's not multiple choice. Keep thinking that, it's not. So you would have to write it and I would have accepted that. Then the range, on this kind, I would not try to draw a picture for the range because I don't even know what it looks like. So I would recommend for the range you think in terms of, on the range, do you get that you have to go from lowest to highest? And what stops you from moving up like that? What kind of an asymptote would stop you? A horizontal asymptote that goes across like this. That would stop you. So the only thing that will stop you on a problem like this is wherever there's a horizontal asymptote. The horizontal asymptotes are the horizontal asymptotes, right? So they're y equals things. And who tells you why? Bob. And is this a Bob bigger on bottom? It is. It's not a SOB, which would be a ratio one. It's not a, what's the other kind? Bot, yes, a bigger on the top. It's not a bot. So it's a Bob. And Bob is an outsider. It's a 0 unless there's something outside the fraction. Is there anything outside the fraction out here? No. So it's just y equals 0. So there we go. Everything works except y equals 0. So I'm going to say all reals except y cannot be 0 because that's an asymptote line. And there, I found my domain and range. Then, to do the inverse of domain and range, you simply flip them, and that's the easy part. So down here, the domain and range of the new guy you just made are just the flip of the original. So the domain becomes a range, and the range becomes a domain. So the range there is going to become this domain, which is all reals except, since I'm doing an x and a y flip, that y becomes an x, cannot be 0. And then the range is whatever we said for the domain. All reals except x, and that becomes y, cannot be -4. Whew, intense. Lots to know about inverses. Let's move on. You can always ask me more individual questions later. Number 8, confirm that they are inverses. That's going to be on there. Pretty much everything in this packet is going to be on there. The reality is that there might be, I would say, like 8 questions that will not be on there out of this packet. No. I can't tell you which 8. I'm just saying you pretty much have to know all these. So if you see that and you go, I'll just hope that's not on there. It's probably on there. Okay. So how do I prove that f of x and g of x are inverses? It says right in the directions there, and it probably would in the question too. Prove by showing that f of g of x equals x and g of f of x equals x. The way I had you always do those is we had a line that ran down the middle, and you had the f of x on one side, or f of g of x, sorry, f of g of x on one side, and the g of f of x on the other side. And then we put the one function in the other function and vice versa, and they should come out to x on both sides. Let's find out if they do for 8a. F of x is 3x minus 2. F of x is 3x minus 2. G of x, on the other hand, is x plus 2 over 3. If I'm going to put g into f, like I said right here, g's on the inside. This one is going to go into that one. I'm going to have 3 big parentheses, x plus 2 over 3 minus 2. Now that should all cancel out and become an x. But again, I have to grade the work on this one carefully. So I can't just look and see did they say x, because I know, and you will know, that the answer is x. Okay? So the cool part is you kind of know it's going to come out to x equals x. So then the hard part is what order you do it in. What should get done first? The multiplies and divides or the adds and subtracts? Multiplies and divides. Those guys get canceled first. Then you show me one step of work after those canceled, x plus 2 minus 2. And now those guys, the plus and the minus can cancel, and I get x. Yay, just like I wanted. On the other side, I got to put the f into the g. This one has to go into this one. Wait a minute. Into this right there where the x is. So I'm going to put an empty spot where the x is, plus 2 over 3. I'm going to drop in 3x minus 2. Again, I know the answer is going to come out to x. You will too. But you got to know what comes first. In this case, the real question is, do I do the top of this fraction first, or do I do the canceling of the 3's first? Which one gets done first? A lot of people get this one wrong. Top of the fraction. Do you know why? How about this? There's a big imaginary parentheses around all of that, and parentheses have priority. Whenever you have a big fraction, there's automatic parentheses around anything that's not a single number. You don't need parentheses on that, right? but on anything that's not a single number, there's parentheses there. So that forces it to be first. So that has to be first, and therefore the +2 and the -2 are the ones that cancel in there. There we go. And now I got 3x over 3, and then the 3's can cancel, and I get x. All right, so that's an example of showing that they're inverses by canceling them out. Next one is one of those acid questions. I would normally say let's just skip it because I've done it so recently, but because a lot of people watch these videos that are not in my classes, you may not have done it this way. So I'm going to show you a way to do that. Amount 1, % 1, plus amount 2, % 2, and this is times in here. And then that equals amount 1 plus amount 2, that's the total amount, and this is the total %. Now let's drop in the numbers where they should fall for problem number 9. 20% acid, and the other is 35% acid. I bet you we're going to mix them. 20% acid, 35% acid. Putting that under percents, of course. How much 20% should be, and how much 35%, ooh, tricky, should be used to prepare 25 liters. Okay, so I don't know how much this is, and I don't know how much this is. For just a minute, I'm going to put a y, but I'm going to show you. You need to go back and change that into an x in a minute. Into a total of 25 liters, this total right here is 25 of 26% acid, 0.26. All right. Now this looks like an equation I could solve, except I have two variables. That's what I have to fix. This will take a little bit of brain power here. If you're trying to get x and something else to add up to 25, and one of them's x, that's it. The other one's 25 minus x. Very good. Now it's only got one variable in it. Now you can solve it. I'm going to say that again. So let's say I had two numbers that add up to 20, and one of them's x. X plus something is going to add up to 20. What's the other number got to be? 20 minus x. That way the x and the negative x will cancel and it'll work. If two numbers, x and something else, add up to 55, x plus what's the other number got to be? Come on. X plus what would make 55? 55 minus x. The only problem with saying x minus 55 is that the 55 is bigger than the x. So we have to say 55 minus x. All right. Okay. So that was even a little bit of a tricky acid problem. That's as opposed to trippy acid, which was back in the 70s. All right. Anyway, now we have a couple word problems where one of the sides is x. We have done those so recently. I am going to succumb to the urge to just skip it because we've just talked about those. So let's go on to a different kind we haven't seen in a while. I'm willing to help you one-on-one on those if you want. You draw a picture, you label the sides of the picture, you make a pure form of the formula, stick the numbers in. Okay, do you guys remember regressions? Okay. Then this part would be your friend because the linear regressions are nice, easy. Just stick the numbers into the chart. Do calculate the linear regression. Do you remember that we had more than linear regression? Yep. They'll tell you what kind it is. But if they say quadratic regression, make sure you use quadreg. If they do cubic regression, make sure you pick cube reg. So you want to do the right kind of regression on your calculator for those. All right, moving on. Get to number 17. We finally feel like we're moving a little bit here. Number 17, do you remember piecewise functions? They're like a little bit of this function, a little bit of that function, a little bit of the other. So they sometimes look kind of like this. It's a little bit of the absolute value function, but then over here it's a little bit of a quadratic function. And then over here, let's say it's a square root function, except flipped or something. So it's part 3 different functions, and it's divided up this way. Okay, yep, like a Frankenstein function. Very good. So let's start 17a and see how that one would look. It's 3 minus x, negative 3 minus x, and that's only where x is less than or equal to 0. So if I'm on my graph, I'm going to pull up a graph here. My content, pictures, there's a graph. Okay, if I'm going to stay less than or equal to 0, then that means basically I got to stay to the left of that line. Okay, so I'm going to check my, weird, how did that, okay. All right, so I need to be this function right here in this area over here. So how am I going to do that? I'm going to make an XY chart personally. I'm going to pick some points, like 0 itself. If I pick x as 0, then I'm going to be on that dotted line there somewhere. If I put in x as 0, I'd have negative 3 minus 0, which would be negative 3. So it's right there. Now I'm going to go to the left from there. So I'm going to try like negative 1. If I put in 0, I got negative 3. If I put in negative 1, put in a negative 1 right there, I get negative 3 minus negative 1, which means negative 3 plus 1, which is negative 2. So it's right there. And is this thing a straight line? Can you tell? It is a straight line, and therefore it's just going to keep going like this. There. That's the function where it's in the negatives. Next part of it. Between 0 and 1, they want us to make the function equal just 1. Between 0 and 1 is this little zone right here. In that little zone, they want the function to be just 1. Y equals 1 is what they're saying. Y equals 1 looks like this. Now this brings up an important point. What did I say was the most commonly marked wrong part of this? The endpoints, the little circles, yes. Who owns 0? If you look at this, can you tell that if that function owns the 0? It does own the 0. So this guy cannot own the 0, so we need an empty spot there. And it's from 0 to 1, and it's like this. 0 is less than x is less than 1. It doesn't own either endpoint. Empty spot there, too. The next one's at 1, 1. All right. Wait, is it actually at 1, 1? All right. The next one is x squared, and it's x squared when x is bigger than or equal to 1. So it's x squared when x is bigger than or equal to 1. So you're right. 1 is owned by the x squared function. If I put in a 1 into the x squared function, it's 1, 1, 1. I put a dot inside the empty circle there, and then I go from there with whatever squared is supposed to look like. So it's over 1 up 1, over 2 up 4, over 3 up 9. There we go. There's one of your Frankenstein functions. Remember to watch those endpoints carefully. As I grade, most kids are going to have it right except the endpoints, and I'll be able to go, oh, nope, nope, and I have to mark it wrong. All right. The first two are Frankenstein functions. C and D are both the kind where you got to know the parent, and then we just move it from there. Do you remember what's the parent function look like for 1 over x? Maybe we should make a list of a few that you could memorize the night before. You remember 1 over x kind of looks like this? I think I've called that the butterfly before. I don't know if that makes any sense, but how about the 1 over x squared parent function? Volcano. Remember that one? If you don't, you should make some notes for yourself so that when you take the test the night before, you can remind yourself of something like that. That's one of the things that doing good notes is good for right now. All right, so if I'm going to take that, the first, well, why don't I do the one that I got on the board here? 1 over x squared plus 2. That means I'm going to move it which way? To the left 2. And then what's that minus 3 do? Down 3. So left 2 and down 3. So I grab the function, which is this red one, and I move it left 2 and down 3. Basically, it would look something like that. All right. Let's see. 5 times the number increased by, okay, yeah, let's start number 18. 5 times the number. You're making an equation here. You should be able to handle 5 times the number. But don't make up a number. So many kids do that. 5 times the number, 5n. Increased by 7, plus 7. Is equal to, we are doing number 18 right now, is equal to the number cubed, again, whenever I say the number, I'm using n, cubed, decreased by 8, minus 8. Show the answer graphically. Actually, that's a really nice thing. It's on the calculator. You'd have to have a calculator for this one. You would just graph both sides and see where they cross. Yes? You know, I don't know the answer to that question. I am going to find out that answer for you. I'll just do an email right now, and I'll probably get an answer pretty quick. All right, so I think I'm going to resume then next time with number 19. That gives you a lot of problems that you can do between now and then. You know, actually, I should help you with number 19. I give you a little bit more. Sorry, but if I'm going to be gone for 2 days, I got to go a little further. So I'll finish up 19 and that'll be good enough. But that'll give you an extra 6 problems you can do, and between now and tomorrow, tonight's homework and tomorrow's homework, that won't be that bad. All right. Those are called Sawtooth functions. They are zigzaggy things like this, and then we do stuff to them. Like the really simple stuff is you go plus 1 and you move it up 1. That's easy. Okay, what are the hard kind? The hard kind are where you do something like absolute value of it. Okay, I'm not going to do the one that's on the test because I want you to just learn how to do it from me, and then otherwise you won't have one to practice. So I'm not going to do the ones that you have, which are 19E and F, but I'll do ones that are just like it. So if my shape looks like this, okay, if that's my original, and I want to do this to it, f of absolute value of x, I think it'd be like that. There we go. If you just absolute value the x's, now think about this. The x's are all going to not be able to be negative anymore. You remember how this one works? Where are the negative x's? Because that's what the ones that are going to get affected are the ones that were negative x's. Do you get, is that left, right, or is that an up, down thing, the x stuff? X is left, right. These things are all the things that where x was negative. Those are the ones that are going to get affected. So on this kind, my absolute valuing the x's means my negative x's can't be there anymore. So what do I do to them? I actually erase them. And did you remember what to do with the stuff on the right-hand side? You reflect it over. So your final answer would be that. You wipe the stuff on the left, and you reflect the stuff from the right to the left. You got to understand what we did over here is we changed this stuff. Why? Because these were the ones that where x was negative, and we absolute valued it, so they're not negative anymore. They're positive, so something has to change. So we wipe out what they were, and we reflect the stuff that was over here onto it. Now, if I go back to my original drawing here and instead do absolute value of f of x, now did I absolute value the x's or the y's? The y's, because remember f of x is exactly like y, isn't it? So we're doing absolute value of the y's. So we're going to try to figure out where are the y's negative. Y's are negative down in here. Those are the kind where y is negative. So do you remember what happens there? You wipe them out, and they're not there anymore. And instead you flip it up. So my final answer would be this part and this part stay the same. But this middle part where they got wiped out underneath, it reflects it up. There's your final answer for doing the absolute value around the whole function. In other words, absolute valuing the y's. That means the word y was negative. They can't be anymore. And they're gone. All right, that covers up through number 19. And number 20 is just kind of your typical word problem. We've done a lot of those. You got to make a picture. You got to label your picture. You got to find a pure form of the formula, etc. All right, I think I need to stop just for my own sanity. So you are now more than halfway through the packet, at least in the neighborhood of halfway through the packet. So please try to finish up through number 20, before we meet again. So try to get up through problem 20, including all the parts, A's, B's, C's, D's, up through 20. Yes, ma'am.
Tomorrow, that means we do all of 20 tonight.
No, I'm saying by, let me think, what day is today? Wednesday. So I think I'm going to be gone Thursday, but you'll be here Friday, don't you? Yeah. So by Friday, I would want you to be done with up to number 20. It is, but there's a lot left, and if we don't do that much, you'd have a ton to do later. You know what I mean? You got to leave yourself a reasonable assignment for later. So, all right, get done with up through number 20. If you could finish them tonight, that's awesome. But at least be for sure there by Friday. Okay, that's all the review I got for today.